All right, so section one, we're going to start with something that I am almost positive that you have seen at some point in your math past. So we're going to kind of go through this fairly quick. There's a reason why we start with this as far as our college algebra. And spoilers, it's already at the top of your page. We're going to talk about the Pythagorean theorem. So our favorite Greek mathematician, Pythagoras, he somehow either stole or invented this theorem that says if you have a right triangle, what a right triangle is it has a right angle, a 90-degree angle. 90-degree angle is hopefully what the floor and the wall are doing in this room. Otherwise, we should evacuate the building. And so traditionally, the sides of a right triangle get labeled A, B, and C. Just for reference, because I might use these words and I want you to know what I'm talking about. So if you don't know them, these two sides that surround the right angle, these are called the legs of a right triangle. And then this long side right here, which I just recently learned how to spell this word. I'm almost 50 years old and I didn't know how to spell this word for a long time. I'm not claiming I'm going to spell it right now. This side, you know, is called the hypotenuse. I think I spelled that right. Yes, I think I did. Okay. So that's the terminology associated with this. And probably you've dreamt about this at some point in the past. You've had an algebra or basic geometry class. But the relationship between these three sides goes like this. If I square the two legs and add them together, then what is that equal to? Everybody knows. C squared, yes. Yes, it's one of those equations that's just kind of out there. The fun thing about the Pythagorean theorem, this is not part of the lecture. Back in the day, they didn't have fun terminology like this. This is the development of thousands of years of going around the world and people writing things down. So we're kind of the beneficiary. The way Pythagoras, he would have devised this and they would have thought about this is they would have drawn a picture. And so they would have drawn a right triangle and then they would have drawn squares. This is how they denoted multiplication, would have been with a square. So they would say the area of this square plus the area of this square is equal to, and I haven't left myself enough room and I'm just making a big mess here, but it's fun, is the area of this square. So it's, to me, just kind of interesting that these areas, when I swoosh them together, become that area right there. You don't need to know that. That's just extra stuff because it's amazing to be in person again. Okay, so we've got a couple of basic examples that are going to get us warmed up here on our sheet. The first one, example one, says, if you have a right triangle with a leg of length 12, so it doesn't matter which one I pick. I'm just going to call this one right here 12. I don't have any units. We're keeping this example nice and simple. And the hypotenuse is length 13. I'm going to give you 60 or 90 seconds. I want you to figure out as best you can. This is, I'm assuming you've had some sort of algebra before because it's college algebra. So I want you to plug and chug and determine what the other leg's length is. All right, so again, I just arbitrarily put the length of 12 at this leg. It absolutely does not matter if we let it be A or B, but I'm just going to go according to my drawing here. So I don't know what A is. That's the side that I've left unmarked. B squared, I'm going to put 12 in there. 12 squared is 144. Maybe I already did that arithmetic. And then the hypotenuse is 13 squared. So now, just want to make sure that we're all awake here this morning and feeling all excited to be in class. Whoops. I don't know what I'm doing. There we go, better. What do I do next? If I'm going to figure out what this value of A is. Yes, thank you. Simple equation solving, which we're actually going to talk a little bit about equations, but but not too much today. So I'm going to subtract the 144. I don't tend to write steps on equation solving, but I will for the first couple, just to make sure that we're all, getting our math, the rust off our brain on our math. So I'm going to subtract the 144 from both sides, and then that turns out to be 25. And then what am I going to do at this point to determine what A is? You're going to simplify by doing what? Not squaring it. I think you mean the right thing, but square rooting it. Yes, we're going to square root. Now, we're going to learn later in the class, when we go into a little more depth of square root equations, that when I take the square root of both sides, there's actually a positive and a negative answer that will work here, because if I was to go back up the ladder, when I square a positive 5, 5 times 5 is 25. When I square a negative 5 times negative 5 is 25. But this is a geometry problem. We're thinking of real space. Lengths are not negative, so we are going to ignore the negative answer on this. Okay, so for now, that'll just be what we do. So the other leg is length 5. Questions, comments, or concerns of our first example of the semester? Congratulations, you made it. All right, well, example 2 says something very similar. Or exercise 1. I labeled them different for some reason, just to confuse us all. For a triangle with legs of length 7 and 24, find the hypotenuse. All right, so this time I've given you slightly different information. We're looking for something a little bit different. I've told you in this problem that the legs are now labeled 7 and 24. Okay, and this time we're finding the hypotenuse. We're finding the longest side. Okay, so that means some of our numbers are going to go into a different spot. So in case you didn't do that, just make sure when you do your problems, read things carefully. So Pythagorean Theorem, I've got 7 squared, that's a leg, and then I've got 24 squared, that's a leg. And this time I don't know the hypotenuse. Doesn't matter what letter you've used, but I'm just turning into algebra mode here. So I used X instead of C. And so 7 squared is 49, 24 squared, that's 476, something like that. I'm a little rusty, forgive me. Okay, 576 equals X squared. What do I get when I add these two things together? Calculator people? Oh, nice number. It's almost like I made it that way. And now when I take the square root of both sides, what do I end up with here? 25. Now, not every square root is going to work out nice and relaxed like that. We'll talk about, excuse me, swallowed wrong. Talk about simplifying things in just a moment when we're talking about our next topic. But up to this point, are we feeling okay about the Pythagorean theorem? Yeah, I'm guessing you've seen that before. I don't think there's anything too mysterious there. So to answer the question, why do we start there with the Pythagorean theorem? It's for this next thing that we are going to use today, the distance formula, distance between 2 points on the Cartesian plane. And it's going to be something that comes back. It's going to come back to us a little later in this semester. So we're going to use it a couple different times. So it's not an eraser, it's a smearer. All right, so I don't have my document camera that's going to be able to record. So I'm going old school, just drawn the Cartesian plane. You've already got it on there. So the distance formula we're going to talk about. So what the distance formula tells me is if I have 2 points on the Cartesian plane, so I'm just randomly throwing down a couple points. Doesn't matter where you put them. I put one in quadrant 1, quadrant 3. There's nothing mysterious or secret that I'm doing there. I'm going to call this point point P, and I'm going to give it the coordinates, let's say x1 and y1. In case you're not familiar with the notation, this is a subscript. It's not an exponent. It's just telling us that we're going to differentiate between this point and the next point. Instead of using different letters, I'm just using different subscripts. This point down here, what did I use on the notes? R. This is going to be point R, and I'm going to call the coordinates of this, because I'm super clever, x2 and y2. Everybody tracking with me about why these subscripts are different? They're different points, so I'm just notating because I'd run out of letters if I use different letters for everything. So what I want to know is there a way that I can determine the straight line distance between those 2 points? Kind of like when you open up your Google map and you get all excited because where you want to go is only 5 miles away, but that's the straight line distance, and then you hit directions and it's really 45 miles away because you got to go on the different roads. Graph theory, super fun. Wish we had time to talk about it. So I want to know D, the distance between these 2 points. So again, the reason we started with the Pythagorean theorem is for this. In order, I can't just subtract, because notice to get from here to here or from up here to down there, what I've done is I've gone a little bit left or right, and I've gone a little bit up or down. So I can't just count the boxes on my Cartesian plane between the 2 points. So what we're going to do is we are going to use this idea of a right triangle to determine the distance. It's actually not really a great right triangle. I'm sorry, I'm not a great artist. All right, so let's think about this. Let's think about so we've climbed up this mountain, okay? What's my elevation change? What's my change in the y? How can I figure that out? How can I figure out what this distance is here? How far I've actually walked up when I've gone up this incline? Any ideas? Yeah, I want to subtract the y values, okay? I started or ended, depending on which way you're going, at this y value. I've gone to this one, so the value of how far up or down I've gone is y2 minus y1. You might say, hey, Perkster, can I do y1 minus y2? Yes, it's not going to matter in just a minute, because if you remember the Pythagorean theorem, this value, whatever it is, I'm going to square it. So it's always going to turn out to be positive. So the order you do this absolutely does not matter. Okay, so if you wrote down, you were thinking ahead because you've seen this before, and you wrote down y1 minus y2, don't erase, you're totally good. So now that we know that about the y values, any guesses on how we can figure out what this distance horizontally is? Perfect, x2 minus x1. Great. Now I have the ability to figure out what the distance d is between those two things. So if you see on the worksheet where I wrote for any 2 points, P and R, in the rectangular coordinate plane, the distance, lowercase d, between P and R, that's how the notation works. So when I go to figure this out, this is the distance d between points P and R. And I'm going to fill this in just a minute. But what we're going to do is we're going to do the Pythagorean theorem. Okay, so this is the end. I'll rewrite it up here when we get it so everybody can see nice, but we're just going to apply the Pythagorean theorem. So my 2 legs, give me one of the legs of that right triangle right there. Sure. y2 minus y1, the y values, that's one of my legs. I'm going to square it, put parentheses around it and square it. So when you actually have numbers, you're going to take that difference, you're going to square it. Just so you got an extra step in the Pythagorean theorem. Plus, what's the other leg? Perfect. Thank you for still being awake. x2 minus x1 squared. Fantastic. So this is my one leg squared, my other leg squared, and then what's the hypotenuse? D, what we're looking for, the distance. And I'm just going to write D. I'm not going to write the whole notation just yet, just for sake of saving it. Are you tracking with me on where the distance formula is coming from? The fun thing is our last unit, we're going to talk about circles. Very fun, probably the easiest thing we'll do all semester. We're going to actually track back distance formula because the equation of a circle is derived from the distance formula. Okay, so you're going to see it some in this section. You're going to see it as we get toward at the end. There's a question about this on the final exam, I believe. So make a little start. Okay, so one more thing so that I can have the distance formula is I don't want it to be equal to d squared. I want the distance, so I want it to be equal to d. So I'm going to do what you told me to do a moment ago when there was just numbers. I'm going to square root both sides. So when I square root both sides, I end up with d is equal to the square root of a big square root y2 minus y1 squared plus x2 minus x1 squared. So I'm just going to rewrite this. This is the distance formula. And I'm going to write it up here and put it in a box so that it'll be up here for the first couple of examples in case you've never seen. I think if you do read the book, there's an e-copy of the book in my math lab. It's actually pretty cool. When you go on examples, there'll be videos of that example being worked. So if I haven't explained something well, or it's late at night and you want a little more exposition, go to the ebook. It's fantastic. So I'm just going to do the x's first for no particular reason, just alphabetical order. x2 minus x1 squared plus y2 minus y1 squared. And this right here is our good buddy distance formula. All right, so I'm going to do the next example just to get us started with this. And then I've got an exercise for you on this. And then we're going to do the same thing with something called the midpoint formula. I wish I had more board space, but I'm going to try to keep this up here because I want to refer to this for the midpoint part of this, but we'll see if that can happen. So my example 2. So if you're following along at home, example 2 on the sheet says this. Find the exact distance. Okay, so we're not going to use a calculator to simplify the root. We're actually going to remember and recall how to simplify radicals. Okay, so if you need a little more help on something like that, that would be something to see me outside of class. I have some videos that I can give you about simplifying radicals. It's something at Polk State, we do an intermediate algebra. So if you had intermediate algebra with us, we covered that in the last unit. If you're here right from high school, I don't know if you did that in your last algebra class. I hope you did. So we are going to find the exact distance between these 2 points. And the first point is -8 and 4. And the second point is 3 and -2. My only word of caution to you in this, and if I had taught you slope back in intermediate algebra, it would be the same word of caution I gave you then, would be careful when subtracting negatives. Okay, make sure you're subtracting the right thing. Okay, so here we go. My distance formula, my d, is going to be equal to the square root of. And I know you can probably do some of this work in your head, and as you work a couple of these, go for it, but I'm going to write everything down so it's all in your notes so that when you look back later and you're working your homework, you see everything. My difference between my x values. Well, what are the x values here? -8 and 3. Remember, I told you, it doesn't matter what order. So if you do this, -8 minus 3 squared, that's fine. Or if you were already working ahead and you did it in the other order, you have 3. Now here's where you got to be careful. It's 3 minus what? -8. 3 minus -8. Well, what do you get when you subtract a negative? It becomes a plus. Okay, so just be careful when you're subtracting a negative. That's honestly, when I give you the test on this unit, that will be the most common mistake people make. You'll remember the distance formula, but some of you will subtract the negatives. Just be super careful. That's why I'm making a big deal of mentioning it right now. Okay, because I don't want you to make that mistake. Okay, plus my y values then are the other ones. So 4 minus, here it happens again, -2 squared. So -8 minus 3, -8 minus 3, that's -11. I'm going to square that in just a minute. 4 minus -2, that's 4 plus 2, that's 6. I'm going to square that. I seriously hope that it's not recording everything backwards. Why is it backwards? Technology is crazy. All right, we'll have to fix that in just a minute. So I will not be posting this video probably because I get a headache watching it. So -11 squared is 121. 6 squared is 36. So it's the square root of 147. At this point, 100, yes. It would be -6, and then you'd square it, and it'd still be 36. So that's why I told you the order that you do the x's and y's in absolutely does not matter, but you just have to be careful of the negatives. Okay, so we should all get the same thing. Another thing, I'll get to you just one sec. Another thing, don't forget that you are squaring whatever this value is. So sometimes students will say, oh, it's going to be -121. Well, it's absolutely not, because that negative is part of what you're squaring. Okay, saw you next. 157. 157. I am just not instilling any sort of confidence in my students, I'm pretty sure. Thank you for that. Were you going to tell me the same thing? Yes, that happens on occasion. I'm just making sure that you're paying attention. Okay, so clearly I never make any mistakes. All right, so 157, I don't know what the factors of 157 are, so I just want to break it down and see if there's any perfect square factors. So real quick, the way you simplify a radical is you determine, is there a factor that's a perfect square? Okay, what are the perfect squares? Well, that's the name of the band. If I had any musical talent that I would start, the perfect squares. So again, I have a video on this. If this is foreign to you, don't remember this at all. But perfect squares, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and we could keep going down the list. And what you're just going to do is you see, do any of these divide into 157? Let me give you just a real quick, simple example, because I don't think this one's going to simplify at all. I don't remember if the next one does or not, but let's pretend, let's say we have the square root of 50. Here's a nice relaxing example. Okay, square root of 50. And you need to simplify this. We're not just going to throw that in the calculator, get 7.1 or whatever it is. What's the perfect square factor of 50? 4 doesn't go into 50. 25. Okay, it's 25 times 2, but you got calculators. That's why let's use calculators. Okay, so just use your calculator, see what divides into it. Okay. The way square roots work is if you're multiplying, not adding or subtracting, but if you're multiplying, you can consider each of these things separately. So that's going to be the square root of 25. You don't need to write that step. But the square root of 25 is 5, then square root of 2. That's the exact answer. Okay, so when it says exact answer, my math lab will say exact answer, and some of them might say round your answer to the 100th. Just do what it says to do. Okay, 157, I am almost positive, unless 49 divides into that, I didn't bring a calculator, so I'm gonna real quick pick up my phone and see. I don't think it does. No, okay. So yes. Yep, just leave it like that. That's the exact answer, square root of 157. So would you please, well, whether you want to or not, exercise 2 is the same sort of problem. Just says, please find the exact distance between those 2 points. If it's a radical that will simplify it all, go ahead and simplify it. Oh, great. Well, I just learned something new. All right, I'm going to get started. If you're not quite done, just keep working. I just try to cut the difference. I know some people get done quick, other people take a little more time. So I'm just trying to hit the middle. Okay, so I'm not trying to rush you. I'm not trying to make you feel like, oh, ashamed that you didn't get done. No, do what you need to do. Okay, so here we go. The distance between these 2 points. Well, the difference between the x's is going to be 7 minus -1. If you did -1 minus 7, you're just going to get the opposite sign. I'm going to get 8 here. So if you reverse the terms, then you have -8. Okay, either way, when we square it, we both get 64. Plus, and then 5 minus 1, finally, I'm subtracting 2 positives. And so 5 minus 1 is 4. If you reversed it, 1 minus 5 is -4. Okay, is everybody with me that we're going to get the same thing? Okay, so just make sure, just be diligent about the order. And so this is 8 squared, that's 64. This is 4 squared, that's 16. If I can add right, which I know everybody's now anxiously looking, this is the square root of 80, right? Yes. Okay, so this can simplify a little bit. I can see if any of the perfect squares go into this. What's a perfect square factor of 80? Yeah, so some of you did this in 1 step, others of you did it in 2 steps, okay? So I'm going to do this both ways on this one because, again, I'm trying to refresh your memory on this stuff. So those of you who said 16, yes, you saw the biggest perfect square factor. 80 is 16 times 5. What's the square root of 16? And then square root of 5, well, it's some irrational number that I don't care about. I'm going to leave it exact, square root of 5. Now, others of you, you started on the perfect square list, and what's the first number you get to? Okay, so when you take the square root is an operation symbol, like a plus sign. So when you actually take the square root of the number, so you on your calculator hit the square root button and it worked. Square root of 16 is 4. So you've done the operation, so you no longer need the square root sign around the part you did the operation for. Great question. So this part, the 5, the square root of 5, it exists. It's an irrational number. There's a whole fun calculus of algebra number, irrational numbers we're not going to talk anything about. So I haven't done the operation. It's going to stay where it is under the square root. Okay, make sense? Fantastic question. I love questions. Thank you so much for being brave enough to ask. Okay, so some of you, though, you went down the list and you got to 4 first, right? So how do I know? Did I get a different answer? How do I know? Well, here you go. So 80 is 4 times what? 20. Now we just want to make sure that it is fully factored. Okay. Now 20, the nice thing about 20, it's a slightly smaller number. So hopefully, you know, we remember our multiplication tables from first grade. Does 20 have a perfect square factor? So I ask myself that same question again. Okay, does 20 have a perfect square factor? Yes, it does. What's the perfect square factor of 20? The perfect square factor of 20 is 4 times 5. Okay. And then 4 times 4, if you want to write 4 times 4 is 16, or if you just want to say square root of 4 is 2, square root of 4 is 2, square root of 5, I'm not doing that operation, so it's going to stay under the radical, and 2 times 2 is 4, so we get the same thing. Okay, so if you start out here, you've done nothing wrong, you're doing a great job, just make sure you fully factor and get all of those perfect square factors. Okay. Questions, comments, concerns? All right, there's one more thing in section 1, and then we'll stop the video and then we'll start the next video, and hopefully this one won't be backwards for the first half of it, because I didn't know you could do that on Zoom. I don't know why you would want everybody to see things backwards, but maybe I would look better backwards if I was reversed. You know, watch that later. Okay, so the other thing we're going to talk about is not the distance between the 2 points, but there's something else that would interest me, is that if I have these 2 points on the Cartesian plane. So sorry if you're going to watch the video later. Red doesn't show up the best, but I've already used blue and green, so red it is. So another thing I want to find is, instead of finding the distance, what if I want to know, I don't know where it is, but I'm just going to put a dot here. What if I want to know what the midpoint, which I'm going to label M, just because I'm super clever. What if I want to know what the halfway distance between the 2 points is? Can I find that? The answer is yes. And this formula is going to be a little bit easier. You're going to be relieved that it's not as many terms as before. So here's how you're going to find the midpoint. You're going to find the midpoint in each direction. So the midpoint in the it's my smear. We're going to find the midpoint in the x and the y direction. So here's how you're going to find the midpoint in the y direction. I'm just going to give this to you. What you're going to do is you're going to add up the two y values. So y1 plus y2 or y2 plus y1, doesn't matter. And then what you're going to do is you're going to divide by 2, like you're taking the average or the mean between the 2 points. So what that's going to give you when you do y1 plus y2 divided by 2, it's going to give you the midpoint in the y direction. So that's going to be the y coordinate of the midpoint. And then you're going to do the same thing in the x direction. You're going to say, okay, the midpoint in the x direction is going to be x1 plus x2 divided by 2. And that's going to be somewhere here. And then those two midpoints are going to give you the coordinates of M, the midpoint. I'm going to pass out the worksheet for section 1-2. While I do that, there are 2 exercises on the back of that sheet involving the midpoint. Why don't you go ahead and give those your best, the best try you can, and then we will see how you do. I'm going to get started on the first one. I'm going to give a little bit of space just in case you made a little mistake, because we're all learning here, so mistakes are totally fine. Okay, that's part of the learning process. So I need to find the midpoint between these 2 points right here. So the midpoint goes like this. My midpoint is going to look like this. The x coordinate of the midpoint is going to be what I get when I add up the x values and then divide by 2. So the x values here are -8 plus 3 divided by 2. The y coordinate of the midpoint is going to be what I get when I add up the y coordinates, divide by 2. So here we go, 4 plus -2 divided by 2. Remember, this time we're adding, we're not subtracting. And so my midpoint is, well, what's -8 plus 3? That is, thank you very much. I appreciate you still being awake. So -5 over 2. I'm going to leave it as a fraction like this. If you said -2.5, that's super good. We don't tend to use mixed numbers, although it's not wrong if you did that. And then 4 plus -2, that's 2. It's 4 plus a -2. Okay, they're going in opposite directions. So that's going to be 2 over 2, and 2 over 2 is just 1. There's your midpoint between those 2 points. So I'm going to give you 30 seconds in case you made a little mistake. Remember, that is totally fine and good. So we're going to get the opportunity to correct it on the next problem. Yes?
So on the test, would it be written as -5/2?
Okay, so the question is, in case you did not hear, because I know masks make everything muffled, is on the test, what do I want? -5 over 2, or do I want -2.5? Because we, of course, want to get the right answer. Okay, so the answer is this. Here's the short answer. It doesn't matter. Okay. The only time it would matter is if this was -5 over 3. A -5 over 3 is, if I go to make it a decimal, that's going to be a repeating decimal. So either leave it, I would recommend just leave it as a fraction. Don't do more work than you need to. But if you really feel like you just got to divide it and give a decimal, make sure you write the repeating decimal appropriately with the bar over the repeating part. Okay. Hopefully at some point somebody, math teacher, taught you how to write repeating decimals. Okay, so just to avoid extra work, because I'm fundamentally lazy mathematically, I just leave it as a fraction. All right, so midpoint formula of this other example. The 2 points are 7, 5 and -1, 1. So my midpoint is going to be, again, we're taking the average of the x values, the average of the y values. So the average of the x values is 7 plus -1. So remember, we're adding, and also this is a positive number, that's a negative number. We're dividing by 2. And then over here, the other one, the y values, I've got 5 plus 1 divided by 2. So my midpoint, m, 7 plus -1 is 6. Divided by 2, 3, that's the x coordinate. And then 5 plus 1 is 6, divided by 2 is 3. So I wasn't real creative on that example, but there you go, we get 3, 3. I'm done with section 1.1 with the stuff that you need to know. Before I move on, are there any questions, comments, concerns? Anything we need to hash out a little more? Okay, well, give me a moment here. I'm going to pause this video. I'm going to start a new one.